Okay, here's a good question. It's one like we did in class. So they give us two solutions. Solution A has this stuff in it. That's A. Solution B has this stuff in it. And then they say they mix them together, making a solution C. And then they say to calculate the concentration in moles per liter of chloride ions. So there's only chloride ions in the first solution. So all I need to do is figure out how many moles I have of chloride ions in that first solution, and then when I add this volume of the other solution, just recalculate. It's sort of like a dilution question. Okay, so let's zero on the first solution. So solution A, it has a concentration of 3.39 molar, and it has a volume of 3.00 liters. Okay, solution B, it has a concentration of 2 molar, and it has a volume of 2 liters. And then solution C is a combination of the two. So the concentration we don't know, but the volume we're adding these two together, so it's got to be 5 liters. Okay, so if they're wanting to know how many chloride ions are in the solution, I have to figure out how many moles. So I need to figure out moles of chloride ions that are in those 5 liters. And I can get that because that's part of solution A. So this concentration is moles over volume. So moles is equal to concentration times volume if you multiply both sides by volume. So the concentration is 3.39 moles per liter times by 3.00 liters. The liters cancel. You multiply those, you get 27, 2, 11, 1, 10. 10.17 moles. So that's how many moles you have total in that solution. Now, if you want to worry about dissociation, and it's a good idea to worry about it, when you put sodium chloride in water, it dissociates into sodium ions and chloride ions. Each of those, because this is balanced, it's a 1-to-1 relationship. So if I have 10.17 moles of this, when it breaks apart, I have 10.17 moles of sodium ions and 10.17 moles of chloride ions. So that's how many moles of chloride ions I have. So now to figure out the concentration, the number of moles is 10.17 moles, and the volume is 5 liters. 5.00 liters. So if I divide that, it would be 2.034 moles per liter. Sig figs, 3 everywhere, so I'll give it 3. So 2.03 moles per liter. I'm picking that answer. Okay, here's another question, probably similar. Let's read it. You have 3 sodium carbonate solutions on a table in front of you. All of them came from a 500 ml volumetric flask containing 3 molar. Okay, how many moles of ions does solution 1 contain? Oh, so I don't have to care about the other ones. So solution 1, let's see. I've got sodium carbonate. Well, let's figure out the moles first. So the concentration is 3 moles per liter, and the volume is 0.1462 liters. So to figure out the moles, I just go moles is equal to C times V. Concentration 3.00 moles per liter times 0.1462 liters. Liters cancel. Now when I times this, I'm going to get, that's a 6. So I'll get 6 0.4386 moles. And that's moles of sodium carbonate. Now the question says, how many moles of ions does the solution contain? So it didn't ask if it's sodium ions or carbonate ions. It just asked how many total moles of solution. So let's write our dissociation equation. So sodium carbonate, if you dump that in water, they'll dissociate. So this is a solid. Dump it in water and you get sodium ions plus carbonate ions. Both those will be aqueous because they're in water now. And then to balance, I need 2 of these. So the ratio then, if I have 1 of these, I'm going to wind up with 2 moles of sodium and 1 mole of carbonate. So if I have 0.4386 moles of this one, then I'm going to have double that. So that'll be 12, 7, 1, 7, 8. I think that's right. Moles of sodium, and since it's 1 to 1, so I'll have the same amount, 0.4386 moles of chloride ions. And these are sodium ions. So they say, what are the total number of moles that the thing contains? So I would just add those two, 0.8. I hope I have those numbers right, but I hope you sort of get this concept. So now I just have to add those numbers, 8, 11, 1, 13. So 1.3158 moles of ions total. I'd call it that one. All right, hopefully that helps you with those 2 questions, understanding moles of the solute versus moles of the ions.